Hi, welcome to Cadence Design Systems Fidelity Tutorial Tuesday, where we will show you how to use a feature or demonstrate a technique in just few minutes. In this video, we will see how zone flux probe command can be used to measure mass flux through complex arrays of passages. The requirement is that the passages can be easily grouped using the available zones. This command is very helpful to measure the flow distribution through individual orifices, especially in combustor effusion liners, which can have thousands of holes. The command, when used based on specified zones, it can identify the location of each effusion hole automatically and simultaneously calculate the mass flow rate through each holes. Let's understand the command with simplified geometry which resembles the combustion chamber. The geometry has multiple flow inlets for hot and cold air. Inside the chamber, dilution holes are provided through which cold air passes and mixes with the hot air. Mass flow data through such holes is very critical in combustion chamber designs. This is the solver input file which is used to solve this simple case. Above you can see the properties of the fluid like temperature, pressure, density are provided for different fluids, then initialized, and further down the boundary conditions are provided for different boundaries. Down below you can see the mass flux probe command which has all the data to write out during the simulation. It has the name of the probe, then the intervals, right intervals, then the interval sampling intervals, then the FS or the zones on at which the liner or the effusion holes are present, and minus and plus keywords represents the direction in which the data is read and written in the output. Once we have the input file, the solver is launched and the Helm solver is currently being used to solve this problem. Once the simulation is launched, the simulation writes out the data of the mass flow at different effusion holes based on the region provided in the input file. Here is the results which is written out by the zone flux probe for the geometry shown. The output file is represented by three main headers, wherein the first header gives the input specification provided by the user. The second header shows the step and the time at which the data was written, the time interval over which the fluxes were averaged, and the total mass flow and their forces across all holes. The third header gives the mass flow rate of the corresponding single orifices, which is provided by the corresponding row and the column of the orifice in that zone. Let us see the results of this sample case. Thanks for watching this video. If you like this video, be sure to click the thumbs up button. Do subscribe to our channel for more upcoming videos like this. If you have any questions or suggestions for our future videos, please drop your comments below or connect with us through LinkedIn, which is linked to this description. Thank you.